So it's time to keep developing our probability work here. And really, you've done really well so far with the first 3 parts in this video series, quite long parts, explaining what probability is, explaining the definitions and how we use notation, explaining relative frequency, and then looking at some basic rules, including a really important things on exhaustive, and then a rule that we call the OR rule, where you add probabilities together. So in this part, we're going to look at possibility space diagrams. Now, that's got a strange name for it. So let's draw one out and then work out why it's called this. So I'm going to toss a coin and roll a die. The options on my coin are heads and tails. The options on my die, it's a standard die. So here is the possibility space diagram. So what I've done here is I've put the 2 events, the die and the coin, on either side. I put the outcomes of these events along there, and then in here I've listed all the possible results that come from combining these 2 events. So a possibility space diagram is where in the space provided on the diagram you record all the possibilities of combining 2 events. Now sometimes you'll be asked to do this in a list format. There'll be a dice rolled and a coin tossed, and they'll ask you to write them down like this: heads 1, heads 2, heads 3, and so on. That's a list of the possibilities. But you can also do it here. Just to make sure we're really absolutely sure, this says heads and 1, heads and 2, heads and 3, heads and 4, heads and 5, tails and 1, and so on. Now actually, we're going to draw out a really important rule from this in part 6 when we look at independent events. But for now, let's just see it as an opportunity to show information. Now here, these outcomes aren't very interesting. But I'm going to now look at a different situation where recording the possibilities provides really productive. So here are a pair of dice. And if I put dice 1 down here and dice 2 down here, you'll see they are standard dice. So my question for you is, what's the probability that the sum of the dice is equal to 7? So that there, probability that the sum of the dice equals 7 is what? So the sum of the dice means it's a combined event. So I'm going to use a possibility space diagram to map it out. Now rather than record 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, and so on, I'm going to record in my diagram the sum of the 2 dice rolls. Now, on one dice, the probability of getting 7 is impossible. You might go, well, it's easy. It's 1 and 6, 2 and 5, 3 and 4. Job done. So it's 3 over something. Then you might think, how many different ways are there to get 2 dice? Well, there's 6 options here and 6 options here, so it's out of 36 perhaps. So we said 7 is 1 and 6, 2 and 5, 3 and 4, so we think it's 3 over 36. 3 because there are 3 pairs, and 36 because there are 6 different options in both. Sounds reasonable. So let's find all the pairs that make 7 when you sum them. So 1 and 1 doesn't, so I'm going to leave that blank for now. 1 and 2 doesn't, 1 and 3 doesn't, 1 and 4 doesn't, 1 and 5 doesn't, 1 and 6 makes 7. 2 and 1 doesn't, 2 and 2 doesn't, 2 and 3 doesn't, 2 and 4 doesn't, 2 and 5 does. 3 and 1, no. 3 and 2, 3 and 3, 3 and 4. 4 and 3, 5 and 2, 6 and 1. So the probability that the sum equals 7 is 6 out of the 36 numbers that go in the grid. Now, let's look at another one. The probability that the total is 10 or more. Pause if you want to have a go. Okay, so first off, to get 10 or more, I need 4 and 6, 5 and 5, 5 and 6, 6 and 4, 6 and 5, 6 and 6. So it's 6 out of 36 again. Now you could simplify both of these to 1/6, that's okay. Or not. What about the probability that the answer is prime? So take a moment, have a think. A number with 2 factors only. So, what's the lowest score we can get is 2 up to 12. Let's then cross off all the ones that have got more than 2 factors. So 2 is 1 and 2. 3 is 1 and 3. 4 is 1 and 4. And then 2 and 2. So I'm crossing it off. 5 is 1 and 5. 6 is 1 and 6 and 2 and 3, so cross it off. In fact, we're going to find more cross off. 1 and 7. 8 is 1 and 8 and 2 times 4, so cross it off. 9 is 1 and 9, then 3 and 3, cross it off. 10 is 1 and 10, 2 and 5, cross it off. 11 is 1 and 11, 12 is 1 and 12, 2 and 6, 3 and 4, so cross it off. So we are left with 2, 3, 5, 7, 11. So 2, 3, 5. If you want to draw them all in the first place, you can do. There's a row of 5s there. 7s. You can see they're always in a row. And 11s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So what we've tried to show here with a possibility space diagram is that by drawing this grid out, it's much easier to get all of the correct options. We can draw it out for any combined events. Some aren't very useful. Sometimes we'll do it just as a list. We then looked at some of the dice getting 7, and we found 3 pairs, so we instinctively put 3 on the numerator, which turned out to be wrong because it was 6. We then looked at a couple of other questions where by identifying them in the grid, we were able to work out their probability quite easily. Now, of course, this could be multiplied, this could be subtract, it could be 2 different dice. It could be a dice that goes 2, 4, 6, 8, 10, 12. But the principle is still the same. What you have to do is draw out your 2 events. Either work out all of these first and then circle them perhaps, or do what we did here, which is just circle the ones you want when you have them. It's time to practice this now. In the next part, we're going to look at biased events before we move into the difficult stuff. Well done.